Artificial intelligence is much different from traditional computer programming. Instead of writing out explicit instructions, you can do something called machine learning. Machine learning algorithms are designed to seek out different patterns in your data. You just need to focus on feeding the machine an enormous diet of data. If you think about it, programming a computer to play chess is an enormous challenge. You could never program every possible move. With machine learning, you just show it the patterns and then let the machine learn its moves on its own. Neural networks are an extremely robust way for machines to find these patterns. Think about the human brain. It's made up of billions of different neurons. These neurons connect together and form networks that allow you to learn new things and quickly classify different patterns. You're very good at finding these patterns, so you might also think it's a simple task for a machine. Unfortunately, what's simple and second nature for you can be extremely difficult for even the most advanced computer systems. So neural networks are about taking what you do easily and scaling it up to take advantage of the speed of modern computers. This means that you can classify several thousand images in an instant, or you can translate to different languages and transcribe audio into text files. Because neural networks are a type of machine learning, you still need very large data sets. You can use supervised learning where you have a small training set and then have the network find patterns. Then you use these patterns to run against your test data. You can also use unsupervised learning where you let the neural network find patterns in unlabeled data. Your network might find new clusters that you haven't considered. This works particularly well for larger data sets. You also might use reinforcement learning. Here the machine can play games or run algorithms and then look at the results. If a positive event occurs, then the machine can learn or reinforce the algorithm. Taking what humans do and scaling it up millions of times has enormous implications for your organization. You could route all your customer service calls to the right location. Maybe you could have machines look through millions of patient x-rays, listen to your customer requests, or even find new business opportunities. Modern neural networks have the ability to exceed our talents when it comes to classifying images. In a few years, it might be possible that machines exceed our ability to translate languages and transcribe audio into text. There are a couple things you want to keep in mind with neural networks. The first is that much like machine learning, you're going to rely on massive amounts of high-quality data. That's how your neural network finds new patterns. If you don't supply the data, then your neural network will not have the opportunity to learn new things. The second thing to keep in mind is that when you're working on a neural network, you're going to be using an empirical approach. That means that you'll run small experiments to try and fine-tune your network to get better results. Modern neural networks give you plenty of opportunity to change your configurations. These are called your network's hyperparameters. There are many dials to turn and numbers to change. There are also different algorithms you can try and many different statistical techniques. Sometimes you might not even know why these changes improve the outcome. But that's part of the experimentation and challenges with neural networks.